Chapter 5.2, Direct Variation. Your objective for this chapter is to write and graph an equation of a direct variation. Before we get started, I want to talk about some vocabulary. A direct variation is a special type of relationship that can be represented by the equation y equals kx, where k does not equal 0. The variable that is used to define the constant of variation is k. K is the constant of variation. It's also the slope of the line on the graph, but when it's a direct variation, it's got a special name, and it's the constant of variation. For example 1, identifying a direct variation. From an equation, you want it to be in the form y equals kx. So we're going to force A and B to look like y equals kx if we can. If we can't force it, it's no. So for A, we have to get y by itself, so we're going to divide by 7. And we get y equals 2/7 x, which happens to be in the form y equals a number times x, so the answer is yes. They ask you for the constant of variation. You're going to say k equals 2/7, so it's whatever number you're multiplying by x. For B, get y by itself, so first we'll subtract 4x, and we get 3y equals negative 4x plus 8. Now we have to get y by itself, so we're going to divide both sides by 3. And you get y equals negative 4/3 x plus 8/3. It's close to a direct variation. Y equals a number times x. Y equals a number times x. But we have plus 8/3 here, which means this one's a no. It's not a direct variation. Guided practice number 1. They want to know if that represents a direct variation. So you're going to first solve for y. Subtract 4x. You get 5y equals negative 4x. Divide both sides by 5. And you get y equals negative 4/5 x. So you tell me, is that a direct variation? And if it is, what is the constant of variation, your k? And then resume the video when you're finished. Okay, the answer is yes, it is a direct variation because it's y equals a number times x, and the number is negative 4/5. Example 2, writing a direct variation equation. Suppose y varies directly with x, and y equals 35 when x is 5. First, they want you to use the form y equals kx, and you're going to plug y and x in to find k. So y is 35, k times 5. Solve for k. So you get k is 7. Now take 7 and plug it back into y equals kx, so it's going to be y equals 7x. That's your equation. Now they just want to know, that's the answer to this first box. Then they want to know what is the value of y when x is 9. So we're going to take our equation, y equals 7x. We're going to figure out what y is when x is 9. So it looks like y is going to be 63 when x is 9. Okay, guided practice number 2. I want you to write the equation. So first you're going to take y equals kx and plug in your y and x and figure out k. Then you're going to plug k back in and find y when x is negative 15. So you are going to get 10 equals k times negative 2. Divide by negative 2, so k is negative 5. Plug that back into your equation, y equals kx, so y equals negative 5x. That's your equation. Now we want to know what y is when x is negative 15. So y equals negative 5x, but instead of x, you're going to put in negative 15, and you get y equals positive 15 times 5, which is 75. That's your other answer. Example 3, graphing a direct variation. They want an equation that relates weight in pounds on Earth and weight on Mars. So they don't tell you as much, but this is a direct variation. So your equation is going to be y equals kx. They do tell you that your weight on Earth is x and your weight on Mars is y. So that's going to be 50 equals k times 130. Then if we solve for k, we get 5 over 13 equals k, which means my equation is going to be y equals 5 over 13x. And I'm just taking the k and I'm putting it right back in up there. That's my equation, and then they want me to graph it. You can graph it by making a table. So we're going to do x, y, and let's say we weighed 0 pounds on Earth, 50 pounds on Earth, 100 pounds on Earth, and we can stop there. If I weigh 0 pounds on Earth, I'm probably going to weigh 0 pounds on Mars, because 5/3 times 0 is 0. Okay, 50 pounds on Earth is going to be y equals 5/13 times 50. And that's going to be about 19. And now plug in 100. So rather than 50, we're going to do y equals 5/13 times 100. That's going to be about 38. Then you just graph the 3.00. Now my graphs have these numbers, but we're not going to use these numbers. So we'll do 0, 0. Then we're going to have to count by something else because our graph doesn't work. So let's say we count by 50s here. Sorry about all the bells. And then up the y-axis, let's count by 20s. 20, 40. Alright, so 0, 0 we've got. Now let's do 50, 19, and then 138. And you'll notice that it's a line and it goes through the origin. All direct variation equations go through the origin. And that's your graph. Guided practice number 3. Your weight on Earth, Moon varies directly with your weight on Earth. A person who weighs 100 pounds on Earth weighs 16.6 pounds on the Moon. What is an equation that relates weight on Earth with weight on the Moon? So we are going to use the direct variation equation. We're going to plug in Earth weight as x, so 100, and Moon weight as y, 16.6, and then we are going to solve for k. And I get 0.166 equals k. Then I'm going to take that and put it right back in up there for k. So y, my equation is y equals 0.166x. Now that I know my equation, I can make my table. So I'm going to do x. This time I'm going to put the process column in the middle and get out my y. So it's going to be 0.166x. Okay, let's say I weighed 0 pounds on Earth. I don't really need to do the middle because 0.166 times 0 is 0. Let's say I weighed 50 pounds on Earth. That's 0.166 times 50. which is 8.3. I'm going to say about 8. We already know if I weigh 100 pounds, that's going to be 16.6. Let's do 150. So that's going to be 0.166 times 150, which is 24.9. So I'm going to say about 25. When I graph this, I'm going to have to change my graph up a little bit. So we're going to say that we are going to count by 50s on the bottom, 50, 100, 150. And then on the y-axis, we'll count by, let's say 8s. Be 24, 16, and 8. So your points are 0, 0, 58, 100, 16.6, so it's going to be 100 a little bit over 16, and then 150 and a little bit over 24. And I have this line, and it goes through the origin. That's very important for direct variation, that it actually passes through the origin, 0, 0. All right, example 4, last example, writing a direct variation from a table. The question says, for the data, does y vary directly with x? If it does, write an equation for the direct variation. When you're using a table, since your equation is y equals kx, k is going to equal y divided by x. So what we're going to do all the way down is we're going to do y divided by x. So for the first one, that's going to be 6 over 4. For the second one, that's going to be 12 over 8. For the third point, that's 15 over 10. And then if you'll reduce those, you get 3 halves, 3 halves, and 3 halves. So that because it's the same every time, the answer here is yes, and we're going to say k equals 3 halves. For B, we're going to do 3.2 divided by negative 2, 2.4 divided by 1, 1.6 divided by 4. I am going to get a negative for the first one and positives for the next two, which actually means that this cannot be the same at all because the signs aren't the same, so the answer here is no. You can go ahead and simplify them, but you'll see that they're not the same. Guided practice number 4, I give you a table. I want you to do y divided by x for each point. Tell me if it's the same, and if it is, the answer is yes, and tell me what the k is. Pause the video and resume it when you have got your answer. So what you'll notice is you get negative 0.75 all the way through, so the answer is yes. K equals negative 0.75. Okay, you have a quiz at the beginning of class tomorrow to check your understanding on the video. Make sure that you understand it. If not, watch the video again. And then bring me your outline to class tomorrow so I can give you your participation.